optimization applications in Excel using our advanced products. My name is Dr. Sima Maliki. I am Consulting Lead and Modeling Specialist at Frontline Solvers. During the presentation, if you have any questions or comments, please type them into the chat box to be answered at the end as time allows. I strive to remain within the promised time frame, yet to thoroughly cover all the material, sometimes it takes a few minutes longer. I very much appreciate your cooperation. As we all know, the optimization applications are widely used across many industries and functional areas. We'd like you to know that many of our customers have found optimal solutions for their industrial problems, worth millions in savings. As building a model can give you insights and a money-saving optimal solution. Today, we explore how optimization can benefit you in solving your business problems and how easy it is to use our tools to solve them. Together, we'll review typical applications in transportation, inventory management, financial services, scheduling staff, and one example of automating optimization using VBA. Maybe you wonder what solvers are good for. So let's start talking about the decision-making process and using optimization to solve a problem. It is always best and most powerful to efficiently allocate your scarce resources arising in your business situations. It can be money, equipment, staff time, transportation fleet, or raw materials inventory. All of these are resources and they are allocated for some purpose. Deciding on which products to ship from factories to warehouses along each route is an allocation of products to routes. Portfolio optimization is allocating money to stocks in a portfolio, and scheduling is really a matter of allocating people to time slots or scheduling the availability of hospital operating rooms, for example. Solvers or optimizers are software tools that help you determine the best way to allocate those resources. Now, if you are wondering what you need to do to use a solver or how to define your optimization model, we're going to drill down on this further. There are three main steps. Each optimization problem involves one or more decisions that must be made in order to solve the problem. Decision variables are typically numbers, reflecting how much of some scarce resource is being allocated to some use or purpose, and that is normally under your control. These decisions need to be made in the best possible way while simultaneously satisfying a number of logical conditions or constraints. Constraints reflect the physical situations, and there are various types of them. Some of the constraints represent limits on available resources, such as inventory or money. There are constraints that reflect the physical situation. One of them is the non-negativity on variables. You cannot produce a negative number of products, or you cannot assign a negative number of people to tasks. Some constraints are determined by policies that you or your organization may set. For example, in a portfolio optimization, you might have a limit on the maximum percentage of funds to be invested in any one stock or one industry group. Then you might also have balance constraints. For example, warehouses are temporary holding points. Therefore, flow out from one warehouse is equal to its flow in. The balance constraints usually have an equality form. And another example is that beginning inventory of this cycle equals the ending inventory of last cycle. Another common element in each optimization problem is the existence of some goal or objective that the decision maker considers when deciding which course of action is best. You can determine objective function by asking, what measures are we trying to optimize? The best or optimal solution might mean maximizing profits, minimizing your costs, or achieving the best possible quality. Now, let's dive in and see how we can solve a problem in practice. Transportation and logistics operations of your company can be a competitive differentiator. So, in this example, let's find out how optimization can be used to optimize a transportation operation. This is about a company that has 3 different goods that have to be shipped from 2 factories to 4 warehouses, and from those warehouses to the 5 customers, or directly from factories to the customers with minimum cost. Here is a diagram of the system with nodes for factories, warehouses, and customers. Now we need to show the supply-demand pairs displaying feasible routes for the shipment plan. And then later I will show you that we will reserve cells for each of the routes. So these gold color arrows show the potential flows from factories to warehouses and customers, and these green color arrows show the potential flows from warehouses to customers. Now let's take a look at the Excel workbook. Let me make sure you can see it. Okay. This is the full analytics solver platform ribbon, which includes simulation, optimization, and also data mining with Excel Miner platform. Today we are going to focus on a subset of Analytics Solver Platform, or ASP, called Premium Solver Platform. And I want to show you how we can change the product. So click on Help and then Change Product. You can see I've chosen the first option, Analytics Solver Platform, but we are just using optimization. So let's choose Premium Solver Platform and click OK. Now it gets updated. Well, some unforeseen circumstance. Let me see. This is really new. I never faced this. Let me try to do this again. Okay. Cool. So now we have the Premium Solver platform, and when you have a free trial, you can do this yourself. Just have to update my license. So Premium Solver platform only allows us to use optimization components. And let's walk through the different options of Premium Solver platform. This model tab, clicking on this, displays or hides the task main. In the model drop-down, there are additional options for multidimensional modeling. And if you need more information about multidimensional modeling, there are examples available and also a user guide. Then we have the optimization model tab that allows you to set up optimization models, including decisions, constraints, and objectives, which we will practice today, how to use them for defining an optimization model. Then we have parameters tab. Here it provides you with the options to run multiple parameterized optimizations. Then we have optimize, reports, and charts. And tools tab allow you to you have the publish button that allow you to publish your models for use and distribution on the web. We have the free Solver app that you might be familiar that is available in Excel. We also have it for Excel Online and Google Sheets. So if you have a workbook that you have developed here, you can publish it and then open it in Excel Online or Google Sheets. Then we have the get data. This is a new feature. It allows you to summarize big data from big data. You can bring in your input parameter data that you would use to drive an optimization model. For example, if you have millions and millions of sales orders in a large database across different hard disks, you're not going to use every single order in your optimization model. With this facility, you can get a sum or average based on region or gender. And if you go to solver.com and scroll down, there is a case study based on using big data and using Excel miner platform, which is beyond the scope here. Now let's go to help. Here you can, as we just saw, we can change the product. You can display online help, use live chat, and control your guided mode, which we will discuss in more detail today. And then you can access examples and also user guides. Here in the task pane, we have the model tab that allows you to view the model elements in place and change them. And then we have the platform tab that allows you to change the platform options, such as number of optimizations to run or default bounds on your decision variables. And then we have the engine tab. Here you can select a solver engine and then set its options. And then output tab gives us a log of solution messages or a chart of objective value. So let's click model tab and review the example together. So as you can see here, I have costs of shipping from factories to warehouses, from factories to customers directly, and then from warehouses to customers. These are inputs to the problem that are not under our control. These shipping costs are quoted to us by our outside shipping company, for example. What is under our control are decisions about how much to ship along each route at these different locations. So let's see how we do this here. We reserve cells for variables representing quantity shipped from factories to warehouses, factories to customers, and then from warehouses to customers. You can see we have reserved these cells. This is how we define decision variables. And then you can see in the model tab of task pane that we have defined 3 sets of decision variables. And then what measure are we trying to optimize? Each route of flow incurs a cost. There are 2 goals that need to be carefully addressed in this problem, the total costs and the service. We want to provide the service with minimum costs and ensure that each customer demand is completely satisfied. As you can see in the task pane model tab, the objective is total cost. And if I double click, it will point us to cell C91. Now let's look at the formula in this cell, the total cost of shipment. You can see it's represented by a sum product function. For example, the first component, to calculate total cost of shipping from factories to warehouses. Since the cost coefficient for these routes are defined in cells C10 through F15, we need to multiply these by total amount of product that will be determined to be shipped. Our decision variables for which we have reserved cells C41 through F46. And similarly, we need to add other costs. Now on to constraints. What restrictions limit our choice of decision variables? The capacity of each warehouse, supplies available from each factory, and the demand from each customer need to be considered. So, here are warehouse capacity constraints. We want to make sure what we ship into the warehouses doesn't exceed the capacity of those warehouses. We cannot overload warehouses as each one has a physical capacity. Then we know that we have a certain supply available at each factory, and they are provided here in these cells, and then here's factory capacity. So we want to make sure total flow out of factory 1 for each product type must be smaller than or equal to the factory supply. And then this is the same for factory 2. And then we want to make sure that each customer product demand is satisfied. So we have this constraint, total to customers are greater than our demand, customer demand. And then our warehouses are temporary holding points. So flow out from one warehouse is equal to its flow in. Again, these are called balance constraints, and they have an equality form, as you can see here. Now we are ready to go ahead and solve this model by clicking on Optimize button on the ribbon. This time we are going to step our way through guided mode and see what it can tell us. This feature is a guide offering help for you in each step of your modeling efforts, preventing common errors. So let's click on Continue. Two things happen here. First, Solver has analyzed all the formulas in the model and determined the structure of our model automatically. And then it is telling us it is the LP convex or linear programming convex. Then, because I didn't choose the right solver engine, it is letting us know and giving us other choices. So I have by mistake choose LSGRG. It's not recommended, and it's telling me to use LP quadratic. So let's do that and then click on next step. Here Solver is telling us that it has found a solution, all constraints and optimality conditions are satisfied. So let's click OK. Now we are back where we were. We get a report in the output tab, and then let's scroll up. Here's the solution. We achieved what we wanted here, which was to determine how best to ship products between the factories, warehouses, and then customers. So to minimize our shipping cost, which is now determined to be $519,700. And then after you have used guided mode for a while and you're solving over and over, you might want to get rid of all these dialogues that you have to click through every time. To make this change, just go to Help and then go to Operating Mode. You can see you have three options. Instead of going to Expert mode that eliminates all the help, we usually recommend to go to Auto Help mode if you don't want to use the guided mode. Otherwise, if you want to keep it, then that's the default setting after installation. So we just looked at how optimization can help us with a typical transportation problem. Now let's look at an inventory management example. This warehouse sells 4 products with a different demand for each product. Each product has a different holding cost and requires a certain amount of space. We have a limited storage capacity. So what is the best ordering policy for a warehouse to minimize cost while meeting demands? As you might know, there is an analytical solution for this problem, which is known as economic order quantity, or EOQ. Unfortunately, this formula doesn't always work in real world. Demand usually fluctuates, ordering time is variable, and other factors arise to further complicate the problem. In this model, we have one such factor, a limited storage space. The variables, as you can see in the model tab, are quantities, called quantities, and then there are actually amounts to order each month for each product. By changing these variables, we change the total cost. And let's look at the formula for total cost. It is cell E17, and then you can see it's the sum of all the costs over all products. Then I can show you that each sum, for example, for each of the product, is calculated by using this formula. Holding cost times average inventory level plus the cost to place an order times average number of orders. And then we have the constraint space used should be less than or equal to the available space for our storage unit. So now let's click on optimize and let's see what guided mode can tell us. Continue. Here it is telling us that this model is nonlinear programming non-convex. Next step, it is found a solution. All optimality conditions are satisfied. Click OK. And here are the results that are how much the amounts to order each month, minimizing our total cost, meeting our demand, and without exceeding our storage space. Now, on to our example in a financial services application, allocating money stocks. And in this example, we will practice defining the optimization model together. An investor wants to target a specific rate of return for his portfolio while minimizing risk. This is a portfolio optimization application, so the goal is to find the best combination of stocks that minimizes risk for a given return. Return, variance, and covariance between all the stocks are known. In order to save time, I have all of this in the workbook, all these numbers. You can see correlations, and then I've defined all the details that we need, like the numbers. Now, the variables in this problem are percentage allocations of the funds that we can invest in each stock. So let's define these decision variables using the ribbon together. I have planned to use these cells, and I just entered 0 in all of them, to reserve these cells C14 through G14 to hold the percentage allocations of funds or our decision variables. So I have already selected them. Now I go click on decisions on the ribbon and choose normal. And I use name ranges and I call them allocations, and you can see that allocations are now added as our normal variables. Next, let's define the objective. The objective in this problem is the portfolio variance. And in cell C18, I've calculated this portfolio variance using a quad product, a custom quad product function. Now, I use my mouse to select this function at cell C18 and then go to Objective on the ribbon and choose Minimize to define C80 as a normal objective to be minimized. And you can see that portfolio variance is now added in the Model tab. Then we have two constraints. So let's see how we can define constraints in a model. The first is a total portfolio constraint, summing the allocations of funds to stocks, which is summing to 100% or 1. So we need to set up one cell in the spreadsheet to represent the formulas of this constraint. Here I use cell H14, and if you look, it's just a sum of all allocations. Now let's select this cell, then use your mouse, click on constraints, and then first one, constraint, and let's use equality to define H14 as the left-hand side. I call it total portfolio. And then in this add constraint dialog, now I can enter either 1 or 100%. Just use 1 and then click OK. And you can see that this constraint is added. Then we have another constraint, total portfolio return. So total portfolio return, we need to calculate it. And I have used cell C20 using a sum product function of all allocations and stock returns. Then we want to define that this must be greater than 9.5%, for example. So let's select this cell and then click on constraints, first one, and then let's choose greater than equal to sign. And then in this add constraint dialog, now we want to enter 9.5%. Then click OK. And you can see it is added here. Both of our constraints are here. Okay, now we are ready to hit the solve button and get the results. And we can use the information in the guided mode to see what is the type of our model. Let's click continue. It is a quadratic programming convex model. And click on next step. And solver found the solution. It has used an engine LP quadratic. So we found the allocations of funds to different stocks resulting in minimum risk or minimum variance portfolio, and that achieves 9.5% return. This is often called an efficient portfolio. You may have heard of efficient frontier too. Using Premium Solver, we can construct that efficient frontier rather easily. Let me show you how. So far in our example, we have used the solver and found the optimal portfolio with minimum variance for a given target rate of return of 9.5%. Now, let's generalize that. We can utilize parametric optimization to find the efficient frontier, that is the optimal solution for several levels of our portfolio return. To do this, we need to first define a parameter. So let's choose an empty cell, for example, D20. I'm going to change the color quickly. So let's go back to Premium. Now select it, click on Parameters, and then Optimization. We insert a parameter. Now this dialog box will open. We want to input 8% for our lower level and then 14% for our upper level, as one of our stocks returns 14%. It's the last one. Okay, let's click OK. Now our parameter is added. If I click on Model tab, you can see that this parameter is here, D20. Now we have to modify our portfolio return constraint right-hand side. Instead of being 9.5%, we want it to point to our parametric return rate. So let's double click on portfolio return. Here we have the 9.5%. I click on this button and then point to D20. Then click OK. You can see the constraint is now updated. Next thing we need to do. Let's click on Task Platform tab of Task pane. Number of optimization to run is 1. But now we want to test, for example, 10 optimization. So let me add 0 here. So we want to test 10 optimization. And I think we're ready. So let me clear this output so you can see optimization's results. So click on Optimize. I'm going to skip guidance. And let me get rid of this GoToMeeting. I'm going to show you that you can see 10 optimizations are finished. Let's click on Model tab. The worksheet will initially display values for the last optimization, but you can display any of optimization results by changing the selection in the optimization number, the Tools tab. So this is optimization 10. I can go to optimization 2. You can see this getting updated, optimization 6, or any of them. Now let's click on Charts and go to Multiple Optimizations and Monitor Cells. Click the objective, portfolio variance, and click on this arrow to move it to the right side. Now click OK. This is the efficient frontier plot. Now we can click on this right button to open the right pane options, and then let's open the chart options. Here you can see X coordinate. We have two options, either optimization index or psi opt prime value. So let's click on the second one, and instead of optimization parameter on X coordinate, we can see the return threshold. Okay, so let me close this chart. Let's go to our slides for a recap on what we learned. And I want to minimize this chart too. Okay. This is a recap on what we practiced, modeling and solving problems in Excel spreadsheets. So you just need to organize your data on the spreadsheet, then reserve cells to hold the values of decision variables, and then pick a cell to represent your objective function and enter a formula that calculates the objective function value in that cell, and then pick other cells and use them to enter the formulas that calculate the left-hand sides of your constraints. The constraint right-hand side can be entered as numbers, as we did, or you can choose other cells, as we also pointed to the parametric return rate, or you can enter it directly, as we did. One quick note is that it is best practice to use constants for constraints right-hand sides. Instead of having formulas that depend on decision variables, we recommend you to move all those functions that relate to decision variables to left-hand side and then use a constant for right-hand side. Okay, now let's look at some scheduling examples. This example is about allocating your staff. It is about an amusement park that needs a certain number of employees each day of the week. Every employee must be on a schedule that gives him or her 2 consecutive days off. How many employees should the park hire and what schedule should they be on to minimize total payroll cost? Let me open the Excel model. Okay. So for these employees working 5 consecutive days with 2 days off, we are looking to find a schedule which meets demands from attendance level while minimizing our costs. So the 7 possible schedules, we have them A through G, and then here we have the decision variables employees per schedule, and you can see it's D 7 through 13, this whole block, and they reflect the number of people hired for each of the 7 possible schedules. And as you can see, they are integer variables. And to define a set of variables as integers, after you define the variables, go to constraints, variables, types, and bounds, and then here you can choose them and select integer. And then our logical constraint, employees per day must be bigger than the required employee per day, which is our demand. And then our objective is payroll, to minimize payroll, and then it is calculated here, and we calculate $40 per hour cost for our employees per day. $40 per day for each person. Okay, let's solve this problem. Going to click escape, let's click on optimize, and I'm going to skip guidance and get the results. So here is the results, the number of people that are required for each schedule. Now, the next workbook is another version of this problem. The park has hired the required employees. Let me increase the size. This is what we have solved. So now it needs to decide which employee goes on which schedule. And then each employee has given a list with his or her preferences, and it is here. So a 7 means the most desirable schedule, and a 1 means least desirable. And we have the schedule numbers, schedule A through G here, and each employee's preferences. How should the park divide the schedules among each employee? Let's go to Model tab. You can see that schedules are defined in these cells, and then they are defined as binary. Binary is like you can just go to constraints as second options, and you define them as binary. So one of the constraints that we have is each employee can be assigned only to one of the schedules. So we have defined a sum here, sum of all allocations for a first employee, for example, this is employee number 1, and then we have a sum over the binary variables for this schedule, and then you can see that we have schedule per employee equals to 1. So this is for all of the employees. I want to make sure each employee is only assigned to one of the schedules. And then employee schedules should be equal to employee required. So we want to make sure we have enough people to satisfy our demand. Now let's look at the objective. So our objective is to maximize total preferences. And this is defined in cell U50. So let's take a look. It is a sum of all preferences. And if we look at, for example, employee number 1 is sum product of array 1, which is the preference list, and then array 2 is our binary variables, which one of them should be 1. So now we are ready. Let's click on optimize and get the results. I'm going to skip guidance, and here are the results. So in this model, we solved the problem after finding the optimal solution of scheduling 1. It is also possible for you to find both solutions automatically. You can write a VBA macro to do this. Let's go back to our slides. So it's a good time to talk about automating your models. Automating your models allows you to run your predefined solver models and control the solver. You can automatically update data, run the model and retrieve the results, and also create an application to distribute to your end users. You can automate your models and control solver engines using VBA Object-Oriented API. In this, we are going to look at the refinery problem, and at the end I will show you that how you can access all the examples. You click on help and then go to examples and optimization examples. So this example is a refinery model. Let me open the workbook. The goal in this problem is to plan the operations of the refinery to maximize total profit. This oil refinery purchases 2 crude oils, crude 1 and crude 2, and then they are put through 4 processes: distillation, reforming, cracking, and blending to produce petrols and fuels, which are then sold. The VBA code for this model shows some of the many ways you can use the object-oriented API, such as how to call the solver and how to retrieve sensitivity information from VBA. So let's take a look at the code. Again, the task model tab shows all the components of optimization model. We're just automating the solution, the solve process. So let's click on Developer, Visual Basic. Here's the code. First thing is with dim problem as new problem, we create an instance of the problem. I'm going to skip details about setting the guided mode. Here we are picking an engine with prop.engine and then set its parameter here. With prop.solve.optimize, we actually run or solve the optimization problem. Then in the next line we are putting a message box, and then we have a for loop, and then again inside that for loop we are getting different message boxes for decision variable, optimization status, and so on. And we will see them as I run the model. Then below that here we have prop.solver report, and then we have answer. Here we're asking for an answer report, and as I run it, you will see that an answer report will be created for us. Okay, so let's close this code and then click on this micro run button. You can see we get the optimization status. I'm going to click through this very quickly. Final decision variable values, and we get the reduced cost, the dual values, and then you can see that finally the answer report is being generated for us here. Okay, let's go back to our slides. You can access our optimization software within Analytics Solver platform or Risk Solver platform product, or you can also get it as a standalone program such as Premium Solver platform that we use today or Premium Solver Pro. Everything that we saw today can be done using Premium Solver Pro or more advanced products, subject to your model size. The Solver upgrade products have very nice usability features, with limits related to problem size, structures, and solver engines. The platform products allow you to add 8 different larger-scale plugin solver engines that you can use to extend the power of these products. It makes it practical to solve very large problems, essentially only limited by your memory. And these engines include Groby, Express, and Nitro, for example. You can do much more with our products. We offer a complete solution for any type of conventional and stochastic optimization problems, simulation and risk analysis, decision trees and forecasting, and data mining, and also text mining. You can find optimal solutions for models with uncertainty using chance constraints, recurse decision variables, and robust optimization and stochastic programming methods. This wide-range product line empowers you to perform analytics on the web and desktop spreadsheets, also web, server, and desktop applications in any scale. Now for a recap. As we mentioned earlier, many of our customers have found optimal solutions for their industrial problems worth millions in savings. We saw today how building a model can give you insights as well as a money-saving optimal solution. We offer you powerful tools to help you get a better solution by automatically diagnosing the model structure for your fixing problem and selecting the right solver engine and providing updated information at each step. Today we just explored one of these features, the guided mode, that help us choose the right engine. If you are asking what is the next best step to begin, please register at our website for free if you have not done so yet. This allows you to access our downloadable user guides, more than 40 example models like the ones we have been showing here today. Furthermore, it allows you to download a free trial at any time whenever you are ready. Try it yourself. After installation, when you have the ribbon ready, you can install Analytics Solver platform or just install Premium Solver platform, then click on Help and then click on Examples. This new workbook will be open for you. And then here, if you want to look at the example I showed today, click on line 19, the optimization, and then brings you different examples, for example, of logistics, scheduling. These are what I showed, refinery. So the 2 examples with VBA code. Or the other examples, click on this optimization example button and then go through these examples. And then these are the dimensional modeling examples. And during this trial period, you have full technical support. You can ask questions. Just give us a call. This is a special number for our webinar attendees, and then you can just send me an email at consulting@solver.com. Now, let me see if you have any questions. If you have any questions, please type them to the chat box. And you're always welcome to send me your questions to consulting@solver.com. One of our attendees asking if these examples available. So just go to solver.com and then register here. I mean, I'm registered and I'm logged in, and just register on our website and then go to, for example, products. Again, if your application only includes conventional optimization, you can use Premium Solver Platform or Premium Solver Pro. You can start with Premium Solver Platform. It allows you to use those larger scale engines we talked about, or you can use Risk Solver Platform. It includes the optimization components, stochastic optimization, and simulation risk analysis. So it really depends on what type of application you have. Or you can start with Analytics Solver Platform that allows you to have the Excel Miner platform for your data mining, text mining application, and so any of these would work for you. But then you can go to change product and change the product to whatever you would like to really, what would works for you the best. So one of our gentlemen asking for stochastic optimization examples. Unfortunately, we couldn't fit it in this time frame, but this is what I want to show you. So we have this YouTube channel, Frontline Solver, YouTube channel, Frontline Solvers, and let me pause this. So I have uploaded different videos, more in-depth videos, and some of these examples we use them today too, but if you click on playlists, here you can have there's a playlist for stochastic optimization. So there are videos on a stochastic optimization, a couple of examples that we review, robust optimization, and using chance constraints, recurse decision variables. All of them are available here. Then you can also review different videos, quick videos on different product lines we have. So this is another source of information for you. Kanaka is asking for parametric analysis example. I don't know if you have been with us from the beginning, but I showed the parameter analysis example when I used the financial application to show you how you can have for that portfolio optimization example. But I believe I also have a parametric optimization application discussed in this. Let me see. Optimization modeling in Excel in these videos here. So, but I can also send this link to you if you kindly email me to consulting@solver.com. So these resources are available to you, the YouTube channel, also examples that I showed you. You can just click on examples. Also, if you need more information, click on help and then click on user guides. There's this main user guide that we have, and a couple of chapters are really beneficial, especially if you want to develop a very large scale model or even small models. I mean, it prevents you from having a model that is unnecessarily nonlinear or non-smooth. So there are chapters on conventional optimization, a couple of examples. There's a discussion on stochastic optimization, parametric analysis, then more information on getting information from the results that Solver gives you, and dimensional modeling. This is a chapter, very good chapter, if you want to automate your optimization using VBA. Then here is a very nice chapter on mastering conventional optimization concepts. So this is very helpful to discussions on more in-depth information about functions of variables and all the detailed information. Then there is also another chapter, building large-scale models. This is also a very helpful chapter, different hints on spreadsheet modeling, optimization modeling, and so on. I hope I addressed your concerns, and also again feel free to contact me consulting@solver.com or sima@solver.com, and I'm happy to point you to right examples. So one of our customers, one of the attendees, Fahad, is asking what are the differences between Excel Solver? First of all, Excel Solver, I mean, I don't, as an optimization applicant, I've been using this for a long time. It doesn't have all the features that we offer here. For example, here you can have access to the task pane. You can see your model elements. If you, for example, send me a model that is been developed with Excel software, usually you can see the references, there are some errors. This easily shows you, points you to right direction, what your decision variables, constraints, and objective function are. You can edit the model elements. You can see the size of your problem. We have improved engines for solving your problems, more advanced options, and again, something like that guided mode is really helpful to prevent errors. I always use it myself, and it gives you more information. If you have a non-smooth model, for example, if you use if functions or lookups, it tells you are developing a non-smooth model, tries to prevent you from making some errors, and those some of them. Then it allows you to run parametric optimizations. You have this publish button, different reports and charts, and also this get data that connects you to big data and bringing large data set, a sample of data to your data set, or a summary of your data set here. So these are just some of the options. With PrimSolve platform, you also have options to dimensional modeling, and you're no more limited by a two-dimensional model in Excel. This allows you to actually, like, if you have worked with GAMS, for example, this is really gives you all the options. You can just have the models the same way. So I hope I answered your questions. Fahad, if you have any more questions, just email me, or you can just type them here. Thank you very much. We appreciate your time. I enjoyed presenting this webinar to you and trust that it was helpful to you. I would really appreciate your comments, feedbacks, and any suggestions that you have. Thank you very much, and bye for now. Tomorrow we have a webinar on simulation and risk analysis, and on Thursday, same time, we have a webinar on data mining. So you're all welcome to join us for those webinars. Thank you again. Until next time. Bye for now.